Hello there, everybody. I hope you're having a wonderful day. Let's make it even more wonderful by doing a little bit more of the 2017 Fryer Contest. So, we got question 3 here. When two chords intersect each other in a circle, the products of the lengths of their segments are equal. That is, when chords PQ and RS intersect at X, PX times QX equals RX times SX. This is actually a very nice result. Back in the day, most people would just have to know this. They wouldn't give this to you, but then again, it is the Fryer, and circle geometry isn't really done in schools much anymore, at least in North America. So we're armed with this nice little fact. Here they've got an example, 3 times 4, 2 times 6, yep, 12. Okay. We got 3 parts to question 3, and it looks like each question involves one of these figures below. 1 light bulb, 2 written. Okay, so we got to step up our game a little bit in that way. Let's do the light bulb. A. In figure A below, chords DE and FG intersect at X, so that EX is equal to 8, FX is equal to 6, and GX is equal to 4. What is the length of DX? Okay, well, they told us exactly the result to use. They're just sort of easing us into this, if you've never seen this result before, here's a light bulb question to very quickly get you into it and get you some marks, even if you don't know what exactly is going on with this circle result. And this is sort of common if they introduce a new concept or a new theorem to people and they haven't seen it before. Light bulb questions can very, very quickly just sort of ease you into how does this work. Very quick calculation with it. So that's what we're going to do here. All right, so I'll draw the circle, even though I don't think we need it for this one. So they intersect at X, and we've got DE, FG. I think this was 4. I think this was 8. And this was 6, I'm pretty sure. Yes, no. Yeah, FX is 6. Okay, they had it the opposite order, but it doesn't really matter. So we know DX times EX equals FX times GX. Well, only one of these is unknown. So DX times 8 is 6 times 4, which is 24. So DX is going to be 24 over 8, which is equal to 3. And that's what we would put in the box, or have just a very quick, therefore DX is equal to 3. Okay, just using the result they gave us. Not a whole lot going on in that one. All right, B and C. So we're going to have to write up a bit more. In figure B, chords JK and LM intersect at X, so that JX is equal to 8Y, KX is equal to 10, LX is 16, and MX is Y plus 9. Determine the value of Y. Okay, so this isn't that bad. It just, whereas before you might have called the DX X and tried to solve for X, we're just trying to solve for Y here, but it's a little more hidden. So I think that was 9 plus Y. I think there was a 10 down here, 16, and J, K, X, L, M. This is 16, and this was 8Y, I think. Yeah, there we go. So we copied figure B. All right, so by the given circle result, or circle theorem, we know, well, what do we know? Without adding in any actual values, we just state what we do know, which is JX times KX is LX times MX. All right, now we plug in some values. So 8Y times 10 is equal to 16 times 9 plus Y. And we're just going to expand this out and solve for Y. So 80Y is going to be 16 times 9. So that's 4 squared times 3 squared. Should be 12 squared, so 144 plus 16Y. Subtract 16Y from both sides, and we'll get 64Y is 144. Divide both sides. So that's there's going to be 16s in both of them, so it's going to be 9/4. Okay. If we needed to, of course, we could just grab our calculators, but we can probably manipulate that in our heads at this point. Yeah, so 2.25, or multiplying that by 4 to get rid of the 0.25, we get 9/4. Okay. Notice that you don't have to do a whole lot of sentences here. Just state your result and very clearly plug things in. If you want to add more sentences, you could say, plug in values. Okay, you could say, therefore, the value of y is... Okay, but you don't really need those things. Okay? Justification and proof does not mean paragraphs after paragraphs of work. It just means everything needs to be laid out clearly, and there needs to be sort of no question as to how did you go from this line to this line. If you think something is confusing, that's when you need a sentence. That's when you need justification. That's when you need to explain, oh, I know this is the only 3 ways you can arrange these numbers, things like that. Therefore, this has to be positive, because how could you have, a negative number of chickens? So, but here, state the result. We plugged in, we rearranged, we solved. We don't need to say what we're doing every time we rearrange. Okay? Only for the hard stuff. So that's B. We got C left to do, and we're going to flip the page because I'm going to copy the picture down for that one as well. I'm going to guess that there's going to be a little z that we have to solve for. Oh no, I was wrong. I thought it might go little x, which we didn't actually have in A, little y in B, and little z in C. That is not the case. Okay, in figure C, chord ST intersects chords PQ and PR at U and V respectively. So they both come from this P up here. So that PU is equal to M, QU is 5, RV is 8, SU is 3, UV equals PV equals N, and TV equals 6. Determine the values of M and N. So I'm noticing we've got sort of 2 intersections here of note, U and V. So we'll probably have to apply this result just considering U as the intersection point and V as the intersection point. So let's copy down our picture. So I know ST goes across like that. I know P goes up here like this. I know it was N here. I think this was M and this was also N. Q and R, I'm pretty sure. And then there were a whole bunch of numbers. 3, 6, 5, 8. 3, 6, 5, 8. Alright, we'll just do one more double check. Yeah. Alright. And because our diagram is getting a little cluttered up with all the black, we'll put U and V in red. Okay. So I might say something like, observe SU times UT is equal to PU times UQ. So what does that tell me? Well, SU is 3, UT is N plus 6. And then what else have we got? PU is M, UQ is 5. Okay, not a whole lot of help there because we got 1 equation and 2 unknowns. But I might call this equation 1, and we might refer to it in a little while. Perhaps expand it out. 3n plus 18 is 5m. Not so bad. But I suspect it's the second equation that's going to let us solve for n, just like it did in B part, and then we can take that and solve for m. So what's the other one? SV times VT is PV times VR. So SV is n plus 3, VT is 6, PV is n, and VR is 8. Alright, so now we've got this equation here. So 6n plus 18 is 8n. 18 is going to be 2n. So n is equal to 9. And I would put a box around this, because if I don't finish the question and figure out what n is, I can probably at least get marks for figuring out what n is. So now I might say something like take n equals 9 and sub into 1. So 3 times 9 plus 6 is equal to 5m. Well, that's 3 times 15, or 45, is equal to 5m. Dividing by both sides by 5, we get m is 9. Okay? So I put a box around that as well, and you might have a little therefore statement or wrapping up sentence. So the values of m and n are 9 and 9, respectively. Although you don't really, I mean, I sort of wrote that on autopilot. I guess they're both just 9. A little odd that we get 9, 9, and 9, but if that's where the math goes, let's see. 6 times 12 is 72, and 9 times 8 is also 72, and 9 plus so that's 15, so that is 45, and yeah, that's also going to be 9. All right, it's weird that they're both 9, but that's okay. We solved the question, and we finished up question number 3. So we got one more question to go on the fryer, and that'll be question 4. I will see you guys for that one in the next video. Until then, have yourselves a wonderful day.